Welcome everybody to the first lesson in our new unit. This is the second part of our trig unit. This week we're going to cover angle measures. Next week we're going to delve into the unit circle and then applications of the unit circle the week after that. Then in the third part of this trig unit, we're going to cover graphing of sine. Well, we are going to focus on sine and cosine, and then we're going to touch on the remaining four trig functions as well. So let's go ahead and get started. This lesson will focus on angle measures. By the end of this lesson, you're going to be able to graph angles in radians and degrees and make sure that they lie in the correct quadrant. Second, you're going to graph and find coterminal angles in radians and degrees. And then lastly, you're going to be able to convert between radians and degrees. On this slide, we're going to be graphing angles in standard position. So every angle in this lesson is going to be graphed on an xy coordinate plane. So here's my x, here's my y axis. And if you notice, the x and y axes are labeled with angles. So these are very special angles that are known as quadrantal angles. Now, quadrantal angles are just the four angles that lie on the x and y axis. So if you notice, these angles are, they're going to start right here at 0. We can see zeros right there. And they're going to be separated by 90 degrees. So if I travel from this axis to the x-axis, that's an angle measurement of 90 degrees. If I go another 90 degrees, I end up at 180. If I go another 90 degrees, I end up at 270. Whoops, let me paste my 2, there it is. And then if I travel another 90 degrees, I end up at 360. So that's where all of my angles are going to go. So when I'm graphing angles, I am going to graph them starting with the initial side. So the initial side of an angle is going to start right here at the positive x-axis. It is going to start right here at the positive x-axis. It's going to travel some distance. We don't know, with some angle measurement. And then it's going to end at what's known as the terminal side. Let's see if we can get a better line than that. There we go. And it's going to end at the terminal side. So we have the initial side, which is located at the positive x-axis. So this is the initial side right there. Then we have the angle measurement. Let's write it off to the side. So theta is just my angle. That's just my angle. And then we have the terminal side of the angle, which is this side right here. So every angle is going to be made up of those three components. And just so we remember what it is, terminal side is just where the angle ends. So angles can also be graphed as positives or as negatives, right? We can have both values. So if we have a positive angle value, these are angles that are graphed by rotating counterclockwise from the initial side. So this one's similar to what to the example just above, right? We're going to start at our initial side right here. Every angle is going to start here. It's going to travel some angle measurement. I don't really know, but it's positive because we traveled counterclockwise. So this is going to be a positive angle. So positive angle measurement. And it's going to end somewhere like that. Now we can also have a negative angle measurement, right? A negative angle is going to rotate clockwise. It's going to rotate clockwise from the initial side. So here's the initial side of my angle. Then it's going to rotate clockwise. And let's say this one goes a little bit farther than the last one. Let's say it ends right around here. So my angle is going to end right around there. Now it traveled some angle measurement, but since it traveled clockwise, then this is a negative angle. A negative angle. It's a negative angle. Okay. Let's go ahead and graph some angles on our xy coordinate plane. So when we're graphing angles, What we want to do is we want to look at the quadrantal angles as references for identifying which quadrant is my angle going to lie in. So you have four choices. If you're in between 0 and 90 degrees, this is known as the first quadrant. If you were in between 90 and 180 degrees, this is known as the second quadrant. If you're an angle between 180 and 270, you're going to end up in the third quadrant. And if you're an angle between 270 and 360, you're going to end up in the fourth quadrant. So let's go ahead and look at our angle measurement. We wanted to graph 40 degrees. We know every angle is going to start at my initial side, 0. So we need to figure out which quadrant it's in. So we know that 40 degrees is definitely less than 90 degrees. So this angle measurement is not going to go beyond that 90-degree angle. So it's going to be somewhere in the first quadrant. So now let's go ahead and graph 40 degrees out. We just are going to approximate it. All right, it's probably, realistically, it's probably a little bit less than that, but we're just approximating it. As long as you get it in the correct quadrant, then that's what matters. Let's look at our next example. So our next example we have is 225 degrees. So 225 degrees. So again, I want to find out which quadrant am I going to be in. The first? Am I going to be in the second? Am I going to be in the third quadrant? Or is this angle going to be in the fourth quadrant? So let's see where 225 lies. 225 is definitely bigger than 90. It is definitely bigger than 180, but it is less than 270. So my angle is going to lie somewhere. The terminal side is going to end up somewhere in this quadrant. So we know the initial side starts here. So from there, theta, my angle theta, which is 225, is going to end up in the third quadrant. And again, remember we traveled counterclockwise because this angle is positive. Let's look at example number 3. This angle is negative 312. Negative 312. Oh, you know what? Let's do red since this one's negative. So negative 312 degrees. So we know that every angle is going to start off here at my initial side. This is negative, so we know that I'm going to travel clockwise. The problem is my quadrantal angles are not negative, so they're not going to help me. I'm going to have to rewrite them, but now in negative. So let's go ahead and do that. So if I were to travel clockwise from here to here, what measurement would that be? Well, that's the same measurement as traveling from 0 to the first or positive y-axis, right? So that is still going to be a distance of 90 degrees, except since I traveled clockwise, it's now negative 90 degrees. If I travel another negative 90 degrees, then 180 now becomes negative 180 degrees. If I travel another 90 degrees, then this is now going to become negative 270 degrees. And then if I travel another 90 degrees, I end up at negative 360 degrees. So my quadrantal angles are now rewritten in as negatives. And now we can go ahead and graph this. Let's see if we can find which quadrant negative 312 is going to be. So negative 312 we know is definitely greater than negative 90. We know it's greater than negative 180. It is greater than negative 270. So that means it's going to end up somewhere in quadrant 1. So traveling from my initial side, I'm traveling clockwise all the way till I go past negative 270 and somewhere in this quadrant. But theta is not the measurement in between them. Theta is my angle, negative 312, is this angle. Right? Starting at 0 and going clockwise all the way around. For the second objective, we're going to identify coterminal angles. The definition of a coterminal angle is it is an angle that contains the same initial side and the same terminal side. So you might be thinking, well, an angle that has the same terminal and same initial side are the same angle. Well, not necessarily. Let's first draw one angle. Let's call this angle theta. So it starts at the initial side. It is going to travel a distance of theta. And let's say it ends there. That's the terminal side. Now let's graph another angle that has the same initial and terminal side, but approaches that angle in from a different way. So let's start here with our initial, and let's travel now clockwise. So let's travel in the negative direction. So if I travel in the negative direction, I can still end up at that exact same terminal side. So we can call this angle theta prime, by the way. So theta prime. So the relationship between these two angles is going to be that they are exactly 360 degrees away from each other. The way we're going to determine that is, let's go ahead and draw a 360 degree angle all the way around this angle. So we're going to draw this is 360 degrees, correct? Well, I'm taking 360, and then I am just going backwards, just whatever theta is. Right? So let's see that again, right? So here's 360 degrees, and now I am just going to go back exactly theta. Right? So now this angle, so now we can come up with a formula for that, right? We know that to find a coterminal angle, let's call it theta. Let's do it in red since our angle's in red. So if I want to find some coterminal angle theta prime, it is equal to whatever theta is, right? Whatever theta is, and then I'm just going to subtract 360 degrees from it. Right? That's exactly what we did here. We went negative 360, and then we just backed it off just a little bit. Let's look at another example. So let's say let's draw our same original angle in the blue. Now let's go a different way. Now let's say I wanted to go this way, but I go past my angle and then end up here, right? I still start at 0 and now I end in the same place, but this time I went all the way around. So let's go and figure this out. So how would I calculate that? Well, this angle in the green goes around 360 degrees, and then it goes just a little bit more, right? Then it goes theta, right? So here, so to find my angle in the green, right, to find theta prime, another way we could do it is I can take theta, and now I am going to add 360 degrees to it. And this is going to be our formula for finding coterminal angles. So now we know that each coterminal angle is going to be separated by exactly 360 degrees.